Check the convergence where xm is given in this form, say 4m minus 3 upon 8m minus 9 comma 3m square upon 4m square plus 3m plus 1 comma 7 upon 6m square plus 5. So how will you check the convergence of this? Correct. Do you remember one theorem we proved? Let me show you the statement if it is there. Yeah. Read the statement. Your sequence xm is convergent where xm is x1 x2 like that. It is convergent if and only if each of the coordinate sequence is convergent. Correct. This is convergent, this is convergent, this is convergent. So that will be good to prove this one. Correct. So to check whether this sequence is convergent, what you have to check? You have to check this is convergent, this is convergent, this is convergent. So how do you check the convergence of this? And where does this converge to? That means you need to find limit m tending to infinity 4m minus 3 upon 8m minus 9. Can you tell me how to solve this? Okay, I will ask with someone. uh, Kanchan, can you hear me? Okay, how to solve this? कैसे solve करें ये limit का question where m goes to infinity? Okay, Ritika. How to solve this thing? Payal, can you hear me? Can you tell me how to solve this? Hello. Shivangi. Perfect, very nice. We'll divide by m. Why are we doing this? Perfect, and we want that, correct? Yes, yes. So we want that when m is goes to infinity, we want the term should be of 1 upon m raised to say k m raised to k where k is positive, correct? This is what we want to make here. Or one more thing, do you remember L'Hopital rule? L'Hopital rule of your FYBSC SEM 2. That means whenever you are having infinity by infinity form or 0 by 0 form. So what is the next step you should do? Do you remember L'Hopital rule? Perfect. Take derivative of numerator and denominator. So both the thing is okay. I'll go by your method. We'll divide by m. So once you divide by m, so this will become limit m tending to infinity. It will be 4 minus 3 by m and divide by 8 minus 9 by m. So this is by m. This will go to 0. This is also going to 0. Answer will be 4 by 8. That is 1 by 2. Correct? What about the second one? Can you quickly tell me the answer? We'll divide by in that case. Correct. Now we are going to divide by the highest degree is 2 and 2. So we will divide by m square. Once you divide by m square, what you will be having? 3/4. Do you agree? Yes. And last one, limit m tending to infinity. What about this? Okay, let me ask with someone. Um, Atharv, Atharv, what is the limit of this? 0. Very nice. Because in the numerator there is no term of m, and in the denominator it is 6m square. That means this term you can consider as m square. So you are having of the form 1 upon m square. I just now told you, when you are having something 1 upon m raised to k, and where m goes to infinity, then answer is going to be 0. Yes. So where does this xm converge now? Xm converge to where? Yes. Hello. Where does this xm converge to? This guy converges to 1 by 2. This guy converges to 3/4. This goes to 0. So xm will converge to 1 by 2, comma, second term is 3/4, comma 0. Do you agree? Yes. Yeah. Okay. Let us do some more problem. When do we say the sequence xm is divergent? When do you say this is divergent? If I'll just give you one example to you. Let us take xm is equal to 1 upon m square, comma 2m plus 1. One more, xm is equal to m plus 1 m plus 2. Okay, what do you think, whether this is convergent or divergent? How do you check xm is convergent? You will see the coordinate function, correct? You will see the first one and you will see the second one. What about the first one? What about the first one? Yukta, can you tell me what about this sequence, whether it is convergent or divergent? Why that is so? We are saying this xm is convergent, or we are talking about this? I'm asking about xm. Okay, why? So what happened m square? See, when will xm converge? As per that theorem, xm will converge if both of its coordinate sequence convergent, correct? This should always converge, this should also converge, correct? But you already know this converges to 0, correct? And what about this one? What about this one? This is divergent, na? This does not converge to this. This goes to infinity. Yeah, so this xm is divergent sequence, correct? Do you agree? Yeah. So for the convergence, we want both of them must converge, correct? But do you see here, for to prove xm is divergent, I just required one of them is divergent, correct? Yeah. What about this one? Whether it is convergent or divergent? It is m plus 1, m plus 2. Everybody is going towards infinity, correct? So all of them is divergent, so xm will be divergent. What about this one? Why that is divergent? Can you tell me? Perfect. Minus 1 raised to m. Yeah, it is oscillatory sequence. And what do you mean by oscillatory sequence? Correct. That means it is a sequence which is bounded but not convergent. Correct. This will be a correct. So this is divergent. So can you fill the statement now? Xm is divergent if when very nice. At least one बोलो चलेगा? At least one of xi raised to m is divergent. Nice. Good. Thank you. 1 up to n. Okay, so I hope this is clear to you now. So let me just ask some more question, then we'll go to the next part. I think convergence will be easy for you now. Okay. Uh, Neha, can you say about this something? Whether it is convergent or divergent? Neha. Okay. Uh, yeah, tell me. Where does this converge to? 11 by 6. What about this one? Because minus 1 raised to m. Is that a region of this? Okay, suppose I am removing this part. Still, do you think this is convergent? If I'm not having this part, that means if I'm having minus 1 raised to m upon 18m. Is this convergent now or divergent again, because minus 1 raised to m is there, as you're saying? Okay, Payal, I think फोन छोड़ के वो बाहर ही गई है कहीं पे. एनीबडी एल्स, कौन बचा है अभी? बात हाँ हाँ हो, बोलो अभी. टेल मी. Whether this is convergent? Wait, now can you tell me whether this is convergent or divergent? Original question. Okay, it is divergent. But if I remove this part, then it is convergent. Okay, can you explain me why? So that I think Neha was having some issue in that. Can you explain why this is convergent? Why do you want to divide? Because it is already in that form, na? It is minus 1 raised to m upon 18m, correct? So minus 1 raised to m, it may be minus 1 or 1, doesn't matter to me. But 1 upon 18m, that is converging to 0, na? So it will be 0 into minus 1, 1, whatever it may be, it will go to 0, correct? Nice. What about the third one? Convergent. And where does this converge to? 2. Nice. This is divergent. Okay, so what is conclusion for xm? Divergent, very nice. Because one of the coordinate sequence of that is divergent. Correct. So is that clear to you? Are you guys able to do this type of question in the exam if they ask something about convergence or divergence? Correct. And there may be some question that give me some subsequence of converge of a sequence. Then these type of question may also be there. Let me just give you an example. Say xm is equal to sine m pi by 2 comma cos m pi. So whether this is convergent or divergent? First question, whether it is convergent or divergent. Shibhangi, can you hear me? Yeah. What is your answer? Okay, why? Okay. And what about cos m pi? Yeah, that is also nice. Okay. Uh, Everybody, do you agree that this sequence is divergent? Everybody? Because this is same as if I write, this is same as minus 1 raised to m. If you understand that. M plus 1 shayad. Because sine 90 is 1. So it will be minus m raised to m plus 1. And cos n pi will be minus 1 raised to n. So both of them is oscillatory sequence and they are divergent. So xm is divergent. Now give me two subsequence of this. Can you give me two subsequence of xm? First of all, do you understand what do you mean by subsequence? If you are having a sequence x1, x2, x3 like this, x4, x5, x6, x7, x8 and so on. Correct? What do you mean by subsequence? You may answer by yourself. I don't have to take name all the time. I hope. Yes, tell me. Neha, you want to say? Okay. Is there a specific definition? That means if I start with any number, correct? So can I go back now? If I'm taking x2 as a first term, can I go back now? That means can I take this one as my second term? No, because that it should be increasing, correct? Suppose this is my first term, this is my second term, this is my third term. Can I take my fourth term, this one? No, correct, nice. So this is I wanted, correct? So your subsequence, if I start with this, the next term should be increasing. It should follow the increasing pattern, correct? So can you give me the two subsequence of this, the above sequence? Hmm. Or I should reframe the question. Can you give me two convergent subsequence? Can you give me two convergent subsequence of the XM? Anybody, if you want, you can answer. Anyone? Did you understand the question? If you write some few terms of this, then also you'll get to know. Atharv, नहीं subsequence देना है जो convergent हो. ये sequence के subsequence देने हैं which is convergent. Try to put the points and see. अगर m equal to 1 put किया तो क्या आता है, m equal to 2 put किया तो क्या आता है, ऐसा put करो देखो. What is x1? What is x2? What is x3? Can you tell me? What is x1? 1 0, correct? कि 1 1. Cos n pi is minus 1 raised to, so it is 1 minus 1 na. See, this is cos m pi is same as minus 1 raised to m, and this is sin m pi is minus 1 raised to m plus 1, I think. Just confirm and then tell me. What about s2, x2? What about x2? Sin pi, what is sin pi? That is 0, na? And what is cos 2 pi? That is 1, I think. See, this is true only if it is odd multiple of pi by 2. I hope you understand. Correct, so I should not write this. What about the x3? What about x4? x3, since it is odd, so it will be minus 1, correct? What about x4? 1. Next. Oh, sorry, what about x4? It will be again 1. It will be minus 1. Do you see some pattern? Do you see some pattern? 1 0 minus 1, then 1 0 minus 1, then 1 0 minus 1 later on,